Right, this is a discussion on properties of matter. Properties. A property of anything is just a description of that item. So for chemistry, we can describe items using three different groupings of descriptions. All items are always going to have one of each of these groupings. So we could be qualitative versus quantitative. We can just make a description using one of those two, or physical versus chemical properties, one of those two, and then intensive versus extensive. So any given description can be classified for each of those different groupings, one of those of each grouping. So our first grouping is qualitative versus quantitative, and you'll see that I have the qual and then the quant underlined because the root words that are found in each of those are helpful in determining the meaning. For qualitative, we're talking about qualities, which are adjectives typically that are used to describe. So for examples, colors, odors, taste, conductivity, reactability, those are all qualitative descriptions of that item. In other words, they don't have numbers, which is what we're going to see in a little bit. The apple is red, it tastes sweet, doesn't readily burn in air. Those are all qualities of an apple. Quantitative, though, is going to be quantities, which means that there's going to be numbers involved. So that's often the easier way to describe or determine if you're looking at qualitative versus quantitative. Do I see a number? If I see a number, it's quantitative. If I don't, it's going to be qualitative. So examples: mass, length, volume, density, melting point, and boiling points, temperatures, the amount of energy a substance contains, etc. So in this case, still using the apple, it weighs 272 grams. There's my number, has a volume of 257 centimeters cubed. Again, my number, and then 53 calories, a number. So oftentimes when you're distinguishing between qualitative and quantitative, look for a number. If you see a number, it's quantitative. If you don't, it's going to be qualitative. Now going to chemical versus physical. Chemical is going to be the substance's ability to react or not react. That's the same. Even if it can't react, it's still its chemical property. Its unreactivity would be also a chemical property. So look for these words, and chemical, physical, distinguishing between those two is often the most difficult, or one of the more difficult groupings, because you have to just know a lot of words, a lot of vocab. Look for react, to corrode, to rust, to tarnish, can oxidize, can combust, can burn, or unreactive. So you could also say can't react, can't corrode, can't rust, can't tarnish. Those are all chemical properties, the ability to react or not react. So for example, a white piece of paper, the white would be the physical, but the paper can burn or it cannot rust. That would be a set of chemical properties, that it can burn, but it can't rust. Both of those are chemical properties. Now moving to physical, it's going to be the exact opposite, not talking about the ability to react or not to react. Just observable things about that object using your five senses. So it's smell, taste, touch, odor, sound. Those would be all physical properties. State of matter is a good one to look for here. Is it a solid, liquid, or gas? And then densities are going to be here, temperature of the item. So a piece of paper has a density of 0.61 grams per centimeters cubed, and it can be measured at 22 degrees C. Could be white, could smell like a chemical, but it's still not a chemical property. So physical versus chemical, again, oftentimes it's easier to decide, can this react, can this react? Look for that react type word. We just talked about those on the chemical page. And if it's not a chemical type word, react type word, it's going to be physical property. Lastly, intensive versus extensive. These are also often difficult for students. And it's again because you have to know a little bit about substances. So intensive, it doesn't matter how much sample you have, that description will always be the same no matter what. I like to think of it as the essence of that item. And then examples of that would be like color, Density is one I want you to memorize here because it's very similar to a lot of the extensive properties. It's a number. Conductivity, reactivity, melting, boiling points. These are useful for identifying substances, so we're going to use intensive properties throughout the entire school year. The piece of paper is white, and it burns at 451 degrees Fahrenheit. It doesn't matter how much paper I have, if I have a note card size piece of paper or if I have an entire paper box. All that paper is going to be white, and all of that paper can burn at 451 degrees Fahrenheit. Extensive, on the other hand, will change based on the sample size. So mass, length, diameter, energy content, the number will change. If I have one piece of paper, I have a single piece of paper, but if I have a whole paper box, I have however many reams times, I think there's 500 sheets of paper in a ream, so I have way more sheets of paper, and it's also going to weigh more because I have a larger sample size. So the piece of paper is 11 inches long, contains 100 calories. Well, if I have only half of that piece of paper, the length will certainly change, and so will the caloric content. And of course, the mass would change, and the calories could be changed if I have a whole ream or if I have a single little speck of paper. The sample size is what changes that description. Now I want to go back to density. Why is it intensive? If we think about a lot of these extensive properties, mass, length, diameter, energy content, number, these are all items that are described using numbers. So most of the time, extensive properties are quantitative. However, density is a number, but it's intensive. And that's sometimes confusing for students because they're like, well, that seems like it's a measurement, or we're doing some measurements to calculate a density. But I have a graph that will show why density is indeed intensive. If we look at this graph, this is showing two objects, object A and object B. Object A, you can see that the dots are packed pretty closely. The dots have the same type of packing up at the larger object. So as the volume increases, so does the mass at the same linear rate, which means that when we take the mass divided by the volume, it's always going to be the same number, which is the slope of this line. Likewise for object B. And then I have an example of how we might use this in class. This is basically a worksheet that we have. If you read this paragraph, you're going to see different descriptions of zinc. I have those highlighted already, and then I have those filled into the table. So I just want to show you how we would go about filling some of these in. Sometimes students just split these columns in half so they can do check marks. Bluish white, is that describing how it can or can't react? Well, no, that's just something I can see with my five senses. That's physical. Qualitative versus quantitative. I don't see a number, so that's going to be qualitative. And then intensive or extensive. If I have a big piece or small piece, does that change what I see? It won't change what I see, so that's intensive. It's always going to be a bluish white. Okay, now burns in air. Burns is one of those words I need to remember. That's a chemical ability. It can burn. Qualitative versus quantitative. Is there a number here? Nope, so that's qualitative. And then lastly, intensive versus extensive. If I have a little piece of zinc or a lot of zinc, it's always going to burn in the air. Low melting point. Melting is not a chemical property that's often confused for students. That's physical. It is a quantitative because there's a number. And then intensive versus extensive. Melting point won't change. It's always going to be the same. 15 centimeter cubed has a mass of 107.1 grams. That'd be a physical property. It's something I can see by weighing it. That's a number. And then these two numbers would change if my sample got bigger or if my sample got smaller. They would both change. That's an extensive property. Reacts with carbon dioxide. I see a chemical style word. Makes it a chemical property. I do not see a number, which makes it qualitative. And if I have a lot or a little, it should always be the same. So notice that most of my choices are intensive for the intensive-extensive differentiation. And then I'm looking for numbers to decide between these two. If I see a number, it's quantitative, N for number. And then I'm looking for those react type words. Again, corrode, burn, tarnish, oxidize, rust, etc. Pause this, go through this example again if you need to, and certainly go back and look at the other slides if that helps you.